This is for Year 12 methods, and it looks at composite functions since the first in the series. A composite function is where you have one function inside of another function. For example, f of g of x, pronounced f of g of x. I can write a shorthand symbol as fog of x, f of g of x. Let's look at an example. Sine of 3x plus 1. This is the inside function, g of x, sine of a function x. So in this particular case, f of x would be sine of x, g of x would be 3x plus 1. So fog, that is f of g of x, is the sine where g sits inside, wherever x appears, g sits 3x plus 1. Second example is e to the x squared plus 2x. F of x would be e to the power of x, g of x is x squared plus 2x, and if I'm placing f of g of x, wherever x would appear I put g of x instead, so I put g of x there and I get e to the power of x squared plus 2x. Third example is the logarithm, log by c of 3x squared minus x, therefore f of x will be log by c of x, g of x is 3x squared minus x, and in fog, g of x sits where x would be, so I end up with log by c of 3x squared minus x. Okay, some situations that might exist when we're taking composite functions. The x goes through g first, then comes out of g and goes through f. So I have a situation where I have my initial input, it has to fit through g and I get an output. That output becomes an input to go through f. I get a final output of the composite function f of g of x. Let's look at f of g of x where it's log by c of x squared plus 1. G of x, the inside function, is x squared plus 1. Its domain is all real numbers, and its range is 1 to infinity, because it's x squared plus 1. F of x, the domain of log base e, is 0 to infinity, and its range is all real numbers. Okay, it goes through g first, so what's going to go in is all real numbers. I might do it in a different colour. What's going to go in is all real numbers. All real numbers will go in through x squared plus 1 and give you an output of the numbers 1 to infinity. That then becomes the input that goes in through f of x, and it needs to go in through log by c of x. The domain is bigger than that range, so it will fit through, and the output will come out, but the output won't be all real numbers because the only numbers that are going in are 1 to infinity. So this output from g of x has to be a subset of the input of f of x for the function to exist. If these numbers can't fit in through f of x, then the function f of g of x won't exist. Let's look at the second example. F of g of x, where I've got log by c of x squared minus 1. The inside function g of x is x squared minus 1. So its domain is all real numbers, and its range is -1 to infinity, inclusive of -1. And f of x is log by c, so its domain is 0 to infinity, and its range is all real numbers. So if I consider that, in my input, going through g first are all real numbers. And what will come out of g of x is -1 to infinity. Now I've got a problem. I can't fit all of that range in through this input because the input will only accept positive numbers because I'm inside a logarithm. So in this particular case, f of g of x does not exist unless we restrict the domain, which brings us to our rule about the domain. For f of g of x to exist, then the range of g has to be a subset or equal to the domain of f. And if it's not the case, then the composite function doesn't exist.